back to my YouTube channel. So today we have to collect this question. We want to show how to use complement, how when the computer is calculating difference of 7 and 17, how to use binary presentation. So now, the two's complement is one of the main ways computer use once it is calculating, or it is performing arithmetic calculation or mathematical calculation. So for sure, here, let us say first solution. To perform this question by using two's complement, we pass through 6 steps as we are going to show them. The first one, first step, we have to change this 17 into, we have changed 17 base 10 to binary using 8 bits. So now, to change this base 10 into binary, you can use two methods. You can use binomial division method or by place value method. So that's for us, let us use binomial division method. Binomial division method. Here, we take 17 divided by 8, then solved by 2. Here it is 8, 16, then 1, divided by 2, then 4, 8, here we have 0, divided by 2, then 2 again, 4, then 0. So now division by 2, here we have 1, then 2, 0. So now, to write these bits, we start from right to left. It means here, 17 divided by 10 is equivalent to 1, 0, 0, 0, 1 in base 2. But we have to write this bit by using 80 bits, meaning that you see here we have 5 bits, then we want to use 80 bits. So we have to add another 3 0 bits here. So meaning that 17, we can also represent this number by saying 0, 0, 0, 1, 0, 1, 0, 1, even base 2. So this is the step 1. We want to change this 17 into binary by using 80 bits. Step 2. Step 2. Change this bit 0, 0, 0, 1, 0, 0, 1 into 1 is into 1's complement. So now, to get these bits by using 1's complement, we invert or we convert 0 bit into 1 and the 1 into 0. Meaning we use a unary operator to show that this is a negative. It can be represented like this. It means 0, 0, 1, 0, 0, 1. By using the unary operator is represented like this. We have to invert these bits. 1, 1, 1, then this one 0, 1, 1, then 0. So this is negative bits which represents 17, meaning that this is equivalent to binary. So now, step 3, add 1 to 1's complement to get 2's complement. To get 2's complement. So now, here we take 1, 1, 0, then 1, 1, 0 plus 1. So now, what you have to remember is, remember that we are SAT7 into base 2. So now we can apply binomial division, log division, binomial division method. You can take SAT7 divided by 2, 18 SAT6, that is 1 divided by 2, that is 9. So then 18 here we get 0 divided by 2, then 4, 8, here we get 1. So now we have 2, then 4 here, 0 divided by 2, 1, 2, then 0. So we write the answer here from. Then what we have to say is this. We have to say SAT7 in the base 10 is equivalent to 2, 1, 0, 0, 1, 0, 0, 1, 0, 1, 1, 0, 1. Remember that we have to use 8-bit representation, so here we have to add the other 0 in base 2. So now, step 5. Step 5, add SAT7 base 10 and negative 17 using their representation, especially binary. So here we have 0, 0, 1, 0, 1, 0, 1. Then plus the binary representation which represents. So no, here there is a mistake here. So here it is a mistake and 2's complement. 2's complement of negative 17 here. Okay, so now, so you can say using like this, using the representation minus. Now we have to take that one. It is 1, 1, 1. So then 0, 1, 1. So maybe here how many bits I do? Here it is 6, okay? Here it is 1, it is 1, 1. So now remember, we are adding the binary. 1 plus 1, we get 2. So that 2 is not element of base 2. We have to divide by 2. We put 1, then 2, 0. We type this and we carry this one. Meaning that here it is 0. We carry 1, then 0 here. You see, then here it is 1. Here it is 3 division by you have to get 1, then carry 1 again, then here it is 0, and then here it is 1, then here it is 0, and here it is 0, meaning we are carrying 1 here, here it is 0, so then we made with this one, here it is like this. So you see, here we get 90 bits, instead of how many bits? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we should have 8 bits. Now, this bit here is called the overflow bits. It's called overflow bits, and it is ignored. It is ignored. It is ignored. Finally, difference of SAT7 negative 16, meaning SAT7 base 10 negative 17 base 10 is equivalent to 2. Even the binary it is equal 0, 0, 0, then 1, 0, 1, then 0, 0 in base 2. So this is the real answer. Computer will represent this number any